I'm going to go over a quick video on how to use your graphing calculator with graphing rational functions. These notes right here that I'm going to be using to go through, it tells you step by step what buttons to push. It starts down here with these 3 steps on how to actually graph these. The other stuff is kind of just to set up and make sure your calculator has everything that it needs to start with. To get these notes, if you don't have them, you can go to Canvas. And under Chapter 8, they were in here for 8.3. If you were in one of my regular classes, yours looks a little bit different, but it's the same thing. Under Chapter 8, it's in 8.3, and it's called the Calculator Notes with Rational Functions. So let's go ahead and get started so this video can not be too long. So again, get those notes so you can follow along with that. The first thing in the notes is just how to set up your window. So if you just click this window button, is the gray button that's kind of top skinny button. It's the second one in. You click that, it says window, and yours needs to say -10, +10, 1, -10, +10, 1. This other stuff down here doesn't matter. And all that means is that when you do your graph, -10 is going to be way over here. So it goes in the x direction from -10 to +10, and then in the y direction, -10 to +10. And then the scale is the one where it said 1 is just these. Each one of these is 1 jump. So you can change that if you want. And that's that X scale, means each one of those marks is worth 1. So if yours doesn't say this for these first 6 things, make sure you change it to this. It probably does. The second thing you want to change is we're going to work with our table. So if you hit the blue button, and then that same button we just hit, above it in blue it says table set. So since we hit the blue button first, you hit that to get to table set. It doesn't matter where this one is. If you want to change it to 0, you can, but that will change as long as it's not something that's really far away from 0. So if it's 100, you might want to change it. But then the rest of this has to be the same. This change in table, that's what that triangle means. That has to be 1. And then they both have to be on auto. What that means is when we actually look at our table, that we'll get into later, it counts by 1s, and then it started at 0. And again, that will change a little bit once we get there. I guess, spoiler alert, I can tell you now, that just because we start at 0, if we hit the up arrow, that scrolls to different numbers. So now, it doesn't start at 0, it starts at -3. So now it has -3 there for that start, so that's the difference. If you ever want to get back to your home screen, you can always hit the blue button and then hit the mode button. See where it says quit up there in blue? So really quick, just a couple things. To make a fraction, I always, and you can see where I did it earlier for my other classes, I always use the division sign and always make sure your numerators in parentheses and your denominators. So the ones I showed you earlier weren't that big of a deal, but for our stuff we're going to do today, it really is important. So make sure your numerators in parentheses, your denominators in parentheses. The parentheses buttons are right here above your 8 and 9 keys. Then last but not least, the X button we're going to use a lot is this one right beside alpha, right beside the green button. It's got an X, a T, a theta, and an N. Those are all just different variables that you use a lot in math. So that's what we're going to be using for your X when you enter this in. So let's go ahead and start entering this stuff in. The example we are going to use is that x squared. I guess I deleted out of it. Let's see if I can open it up quick. So if you're looking at the notes, the one we're going to use is this one right here, x squared plus x minus 12 over x squared minus 4. Sorry, let me get back to this. So there's really 3 steps to this. The first step is entering your function. The second step is graphing your function. And the third step is looking at the table so you can graph by hand. So first thing, to enter your function, you're always going to, anytime you ever graph, you always have to go to this y is equal to at the very top. So hit y is equal to. If you ever have anything else in there, you just want to hit clear to get rid of that. And then you're going to type in this fraction as a division problem. Make sure your numerator goes in parentheses and your denominator goes in parentheses. So my numerator is x squared plus x. So I have x squared plus x minus 12. And then your other parenthesis, don't forget that. Then divided by, and then another parenthesis, x squared minus 4. Both in parentheses. So that's entering your function in there. Now that function's entered. So the next thing is graphing it. Well, it's really easy. All you have to do is hit this graph button. Now you can see it draw out, and that's kind of nice because every time it jumps right there like that, and right there where it jumps, those are both asymptotes. The problem is, with the graph, you can see your asymptotes really well, but you can't see any holes. So the way we can tell where the holes are is by using our table. So the next thing to do is look at your table. So to get to the table, you hit the blue button, and then it's the same button as graph. It says table above it in blue. So this is our table. Every time you see an error, it's either an asymptote or a hole. And so that's the problem. Your table will show you where the asymptotes and holes are, but you can't tell which is which. Your graph shows you the asymptotes, but it doesn't show you the table, or sorry, it doesn't show you the holes. So we have to use those together to make sure we can see both of those. So that's the first thing, just how to graph one of these, and then we're going to talk about asymptotes and holes a little bit later. Again, the asymptotes are where it jumps right here, and the best way to describe a hole, especially with this calculator, it's if there's ever an error but there's not an asymptote. The problem with this example is that there's two places where it shows up as errors, and they're both asymptotes. So at -2 and +2, and if you look at your graph, -2 is right here, +2 is over here. So let's do a couple examples I have written up here where I have. So we talked about this already. So that's how to do it in your calculator. So that's how we can start this one. Actually, I should say, so if you need to go and rewatch some of those for examples, you can. But I already put this one on my calculator, so I'm going to go ahead and put the table here. And then I'm going to show your graph, and then I'm going to find all this stuff. The only thing that I maybe didn't talk about, and I did a little bit, but I'll reiterate. So my PowerPoint, the table starts at -6 right here. And so on your graph, if your table doesn't start at -6, so mine doesn't start at -6, just hit the up arrow until you get to -6. If you want to go down then to +6, you just hit the down arrow until you get to +6. So again, I already put all these in the calculator, so I'm going to go ahead and write up the table here. If you have a table that's wrong or something, go back and rewatch this video and make sure you mimic how to put this fraction into your calculator. So when I put this one in my calculator, and I always round the table, I always round to 2 decimals. Technically, you probably could only round to 1, but I always like 2 is a good number for me. So -6 at 0.13, -5 is 0.19, -4 is 0.33, -3 is 0.8. -2 is an error. So I don't know if you can hear me, the computer's way over there. -1 is -1.3. 0 is another error. -1 is -1.3. 2 is another error. 3 is 0.8. 4 is 0.33. 5 is 0.19, and 6 is 0.13. So let me move this computer so it's a little closer to me while I do these carefully. So that's the table, and now we're going to use that table to graph by hand. Now definitely don't put this big dot over here. When you're graphing this, don't just look at your graphing calculator and just try to draw it in as best as you can, because if you do that, it's not going to be accurate enough. It's going to look correct, but it's not going to go through the points I want. So the first thing I'm going to do is I'm going to graph all these points. So -6 goes to 1.3, so that's just barely above that. -5 goes about the same height, maybe a little bit higher. -4 goes to 0.3, and so all these are just estimations, but you can kind of see where it's going. And then -3 is closer to 1 at 0.8. And then there's an error. So when there's an error, just leave that blank for -2. So -1 is -1.3, so -1.3 is down here. 0 is another error, so just leave it. +1 is a -1.3 again. There's another error at 2, so just leave it. And then 3 is at 0.8. 4 is at 0.33. 5 is at 0.19, and 6 is at 0.13. So this is where, put all those points on there, and now look at your graph. Because now if you look at your graph, you can see that there's an asymptote here, and an asymptote here at 2. So your asymptotes are both there. And again, we know they're asymptotes because if you look at your table, you have an error there. But don't forget, these errors on the table could be either asymptotes or holes. So that's why you need to check. So this 0 also gives you an error. But if you look at your graph from your calculator, there's no jump there. It's just a smooth curve. So when I graph this, we have a smooth curve here. Now it doesn't ever cross that asymptote. That's the whole point. That's why I draw the asymptote in there, because it doesn't ever cross that. Same thing down here. It'll go up, doesn't ever cross it, comes back down, doesn't cross that one. And this one starts over here and doesn't ever cross it as it goes up. Technically, these should have arrows, but as long as you go across your whole graph, I just leave it like that. And last but not least, we said this is an error, but it's not an asymptote, so it is an open circle. So just make sure you draw that little open circle in there so you get full credit for that. So now we have the graph and we have the table. We can use those as a team kind of to find what these are. So our vertical asymptote, we already know those, is x is equal to +2 and -2. Try to remember to put the x is equal to because they're vertical lines. There is a hole at 0. So I just put x is equal to 0 because that's where that hole is at. Now again, that doesn't mean there's no zeros. That just means there's a hole there. Now for the domain, you always start with a brace. Whoa, that's an ugly brace. You start with a brace, and then an x, and then a bar, and then an x does not equal to, and then that's the only thing that's going to change. So we'll put our other brace there. So the only thing that's going to change when you draw the domain is what's in here. Other than that, it's always going to be the same. It's always going to be the x, the bar, the x is not equal to, and then the thing we write in here is all the errors. So the asymptotes and the holes. So I have 2, 0, and -2. Kind of a sloppy over there, ran out of room. Last but not least, the x-intercepts. Now, if you can't tell where the x-intercepts are from your graph, where it crosses your x-axis here, look over your table. Your x-intercept should have a 0 for the y. If we don't have any, you need to put the word none. Don't put 0, put the word none, because if you say 0, that means you're saying there is an x-intercept at 0, so just put none. Now, the last thing I'll say about that is that word none could be for any of these. You could have some that don't have a vertical asymptote. You could have some that doesn't have a hole. Just put the word none there. That's fine. And again, if you actually graph this and look, you'll see that there's not an asymptote here. There's a hole. It doesn't jump anywhere. And you can see just the way I wrote it up here that it doesn't jump at all. I would show you on the calculator, but I want to make this a short video. Number 2, same thing. So -6 is -2, -5 is -1, 4 is 0, -3 is 1, -2 is 2, -1 is 3, 0 is 4, 1 is 5, 2 is 6, 3 is 7, 4 is an error, 5 is 9, 6 is 10. Now this is going to go off my graph a little bit, but that's okay. So when you graph these, it's not too bad. -6 is -2, -5 is -1. Oops. You should also make sure you know how to graph. -6 is -2. That's down here. -5 is -1. -4 is 0. -3 is 1. -2 is 2. 3. 0 is 4. 1 is 5. 2 is 6. 7. There's nothing at 8. That's an error, so leave it. Oh, sorry, there's nothing at 4, which is up here. There's nothing there, so just leave it. Then 5 is up here at 9, around there, and 6 is up here around 10. Now again, I know 4 would go through 8, but it doesn't because there's an error there. Well, if you look again, there's not an asymptote there, so I hope it's pretty obvious that that's going to be a hole. So that's an open circle there at 8. So this is what my graph looked like. So again, just like I said before, vertical asymptotes, there are none. There's none of those places where it just jumps. It's a smooth line. There's no quick jumps in there. If you look over here, there's only one error, and there's not a jump there. It goes from here to here. So that's got to be a hole, not an error. So where's the hole? The hole is at x is equal to 4. Don't put 8. I know that would be at 8, but the hole is at x is equal to 4. So your domain, again, the same thing. We have a brace, bar, x does not equal to. There's no asymptote, so it's just that hole at 4. And the x-intercepts for this one, again, you can either look at your graph to see where that crosses the x-axis, or look at your table wherever you get a 0 for your y-intercept. So for my y-intercept, it is -4, 0 is where that's located. So that's a little bit of a unique one. And if we go over how to do this by hand, you'll notice why it ends up being a line. I guess real quick, if we were to reduce this like we did before, we factor that out, we get something to cancel, and so now all we have left is x plus 4, which is slope-intercept form, and that's why my y-intercept was 4, my slope was 1, but the whole is still there at 4 because we can't have x be 4, it's an excluded value. I know that was quick, but just a small explanation. And the last one, number 4, so we have 0, 0.07, 0.33, then we have an error, then negative 1, negative 0.83, negative 1, negative 1.75, error, 1.5, 0.71, 0.46, and 0.33. So when we graph these, negative 6 is 0, negative 5 is just barely above 0, negative 4 is at 0.33, a little higher, negative 3 has an error, so just leave it. Negative 2 is negative 1. Oh, yeah, sorry, negative 2 is negative 1. Negative 1 is just barely above that. 0 is negative 1. Negative 1 is negative 1.75. Then there's an error at 2, so leave that. 3 is at 1.5. 4 is at 0.7. 5 is at 0.46. And 6 is at 0.33. And again, some of these are a little bit of an estimation. A lot of them are, but that's okay. Now again, before you draw this graph in there, look at your asymptotes. Because a lot of people, when they draw this, they'll just draw like this. Well, you don't realize you just want to cross your asymptote, and you can't do that. So make sure you look at your graph and make sure you're studying that. So I like to draw in my asymptotes. So I have an asymptote here. I have an asymptote here. Can't cross those. So this one comes and looks something like this. We have another kind of goes down in like a U shape. Again, we don't cross those asymptotes ever. Then over here we come and go up. So we have two asymptotes. They're the errors over here. So we have x is equal to negative 3 and positive 2 are the asymptotes. Then those are the only errors. If you look over here, there's no more errors, so the holes are none. There are none. So our domain, x bar, x does not equal to negative 3, 2. Those are the errors. Then the x-intercepts for this one. Now the hard one is if you just look at your graphing calculator, it's really hard to see this. Even if you draw your graph correctly, it's kind of hard to see, but that's why it helps to use this table sometimes, because wherever your y is 0 is your x-intercept. So my x-intercept is negative 6, 0 for that one. So again, if you're not getting these graphs, if you don't know what to do for those, again, go watch the beginning part of this video where I show you how to put this stuff in your calculator. That'll help you see what the graph is and see what the table is. I tried to save some time, so I did the calculator part first, so you can rewind to that. Then hopefully, when I explain this, you understand the vertical asymptotes, the holes, the domain, and the intercepts. So if you have any other questions, make sure you let me know.